All right, Chem 107. Today we are going to be, or this week I should say, we're going to be doing gas laws. And I should also say, I hope you guys are all doing well and everything is going okay at home. Um, so gas laws, I'm assume you've covered this in lecture, although I'm not entirely sure. So I'm going to go through some of the stuff, but you can read through this introductory information if you want to. A couple things I want to point out to you right now. This table right here we will be using for the lab. Okay, so you're going to want to reference that in a little bit. And hopefully you have watched the video for the lab setup. If not, you can go back and watch it after you watch this video. It doesn't matter really what order you do it in. Okay, but what we're going to be doing, I'm just going to draw a really quick picture here. You don't really need the procedure for today. So I'm going to just use this blank page and I'm going to draw a picture of what you're doing. Okay, and it's going to be a really bad picture, so you're just going to have to kind of deal with that. All right. So we're going to be reacting some magnesium in a flask, as you saw in the video. Yeah, I know that's terrible. We have magnesium plus HCl in the flask, and then we had what we called the eudiometer. Okay, and then there's a hose connecting them, and the gas goes up into the eudiometer, and the eudiometer is filled with water. Oops, that was supposed to be blue because it's water. There we go. Filled with water. And that hydrogen gas is going to bubble up through the water and fill that top portion. So we're going to get H2 gas up here. Okay. And of course that water is liquid, but in addition to the liquid water, what's going to happen is some of that water is going to evaporate. So we will also have H2O gas up here. So because of Dalton's law of partial pressures, we know we can add the pressures of various gases. So we know that the total pressure inside that eudiometer, I'm going to just come down here, okay? So P total is equal to the sum of the partial pressures. So the partial pressure of hydrogen gas plus the partial pressure of the water, gaseous water. Okay, those are partial pressures. And if you're not sure what a partial pressure is, you may need to go back and review your lecture notes or shoot me an email. Partial pressures. Okay. So obviously we have three variables in an equation here. And if we know two of them, we can solve for the third. So P total, that is going to be atmospheric pressure. P sub atmosphere. Okay, that you get from the video. And when I say the video, I don't mean this video. I mean the video of the actual experiment. Okay. This P sub H2O you get from table 1. Remember that table I highlighted? And it is based on temperature. So if you look at table 1, the higher the temperature, the higher the partial pressure. That simply means that more water is evaporating at a higher temperature. Okay, and it's going to give you, it only goes like 19, 20, 21, 22 degrees Celsius. Just pick whichever one is closest, so it'll be fine. Okay, so if we know those two things, why is my pen not working sometimes? All we have to do is solve for P sub H2. Okay, that's the basic premise of the lab. Well, I guess the basic premise of the lab is we can calculate how much magnesium we should get from the, we can calculate how much hydrogen we should get from the magnesium, and then we can compare it to how much gas we do collect in our eudiometer and see if the reaction was as efficient as we thought it was going to be, basically. So how are we going to figure out how much magnesium we get? Well, I'm sorry, I said it again. How much hydrogen we get from the magnesium? Simple stoichiometry. Magnesium solid plus HCl gas That's not a gas. That's aqueous. There we go. We get MgCl2 aqueous plus hydrogen gas. Okay, and of course this is not balanced, so we need to put a 2 there. But using stoichiometry, we can convert from moles of magnesium. Okay, if we know moles of magnesium, we can get a mole ratio to convert to moles of hydrogen. And of course, if we want to go from moles of magnesium to moles of hydrogen, our mole ratio would be 1 mole of H2 per 1 mole of magnesium. So what does that mean? It means it's actually the same numerical value, it's just a different unit. Okay, so let me walk you through this report sheet here, and I'm going to kind of annotate it as we go. All this stuff, so there's that information from table 1, but all the rest of this stuff you're going to get from the video. And that was made by one of the other lab 107 instructors, and she did a really good job. So anyway, then we have in that next table down there, it says moles of magnesium. How do we get moles of magnesium? Well, up above here we have mass. So what we're going to do is we're going to use the molar mass of magnesium to convert. Okay, you guys ought to remember how to convert from mass to moles. Okay, and then I already showed you how to do this problem. Moles of hydrogen gas, which is our theoretical yield of hydrogen gas. Okay, that's using stoichiometry. So you're going to take that moles of magnesium from up above, the mole ratio I showed you right here, and you're going to get moles of hydrogen gas. Okay. And let's see, room pressure. Okay, that's from the video as well. That's the barometric pressure. All right, partial pressure of dry H2. That's the value we're going to solve for in that little equation using Dalton's law of partial pressures I gave you. Okay, so basically P sub H2 is equal to P total from above there minus P H2O. Okay, and if you don't put these all in the same unit, it doesn't work. They all have to be in torrs. Okay, you can't have millimeters of mercury, atmospheres, and torrs and do subtraction and get it to work out. Okay. So then let's see, temperature. That's just the room temp. That's from the video. Okay, N experimental from the gas law. What's the gas law? PV equals nRT. I was going to do that in a different color. Isn't it fun watching me do this as I go? PV, it's almost like being in class, equals nRT. Okay, we're going to solve for n. Solve for n. Here's our T. Here's our P. And let's see, where is our V? V is up here. Okay, and then R, that's just the ideal gas constant. And then percent yield, okay? Percent yield, simple enough. Percent yield is equal to actual over theoretical, all times 100, okay? So where do we get actual? Well, that's from an experimental. That's the previous step right there. And theoretical, that's moles of gas right here. Okay, and then just multiply by 100. Here you got to show your calcs. You got 3 trials. You only have to show 1 trial as usual. And then you just got to answer the post-lab questions. Couple things. I would like you to upload these in Blackboard. Please do not email them unless you cannot get the Blackboard link to work. It is much easier for me to grade them if they are already in Blackboard. So upload them. Do not email them. Email me if you have a question. Absolutely, I'm perfectly happy to answer. And I've been checking my email a lot, so I can get back to you within a day or so. All right. Good luck.